All right, welcome back to Chapter 4. Today we're going to jump into Section 3. We're going to start talking about what's called the determinant. Before we start talking about what it is and how we calculate it, I'm going to talk about how we symbolize it. Your book, a lot of the time, uses just the letters DET and then A to symbolize that they want the determinant of A, of matrix A. Some other things that your book may do, I've seen it determinant A, or it looks like absolute value bars around it, but in fact it's not absolute value. These are two ways that we are going to symbolize the determinant. Your book uses both of them for different times, so I tend to lean towards the bars to symbolize the determinant just because that's what I like. That's how I've always done it. So I will use both, but for the most part I'll use absolute value bars or what look like absolute value bars to symbolize that is the determinant. Next thing we want to talk about, a determinant can only be defined on a square matrix. Okay, so I'm talking a 2 by 2, a 3 by 3. So I have to have the same number of rows and columns. Now, scrolling down, I just pulled this from your book because I think it does a good job of showing how to calculate this. The determinant of a 2 by 2 matrix, looking up at the top here, I've got matrix A, B, C, D. So down and to the right, we're going to take as our positive. So A times D is going to be the first one. We always start in the top left going down to the right. Now, if we start at the bottom left and go up, we're going to subtract that. We're going to take that as a negative. So we're going to subtract C times B. We're going to multiply those. Most people like 2 by 2 matrix determinants a little better than the 3 by 3 because they are quick and easy. Multiply the diagonals and subtract them. Just make sure you subtract the right one from the right one. When we go down to a 3 by 3, it gets a little hairier. So I've got A, B, C, D, E, F, G, H, I. I've now got 9 numbers in this matrix. I've got 9 entries. So if you look, I can go down and to the right diagonally 1 full round. But what I need to do is I need to worry about this DF and this C going down and to the right. So what you do is you are going to copy the first 2 columns down to just to the right of the matrix. So A, D, not B, D, G, and B, E, H. And now you can get those three diagonals from the top left corner down to the bottom right. You get that 3 times. So you're going to get A times E times I, which is just like we did with our 2 by 2 matrix. But now we're going to get B times F times, and if I was a better artist, drawer, that would go down to G. So you can see it here in blue right next to where I wrote. So we're going to get B, F times G, and then I'm going to get C times D times H, which the D and the H are both coming from copying those 2 rows, or those 2 columns right next to that matrix. Then I'm going to add all those up together. Since those are all my positive directions, I'm going to add up all my negative directions in red, and I'm just going to subtract those. So I'm going to take G times E times C, working bottom left to top right. Then I'm going H times F times A, and I times D times B. I add those all up, and subtract those two answers. You want to get down to two numbers that you're just going to do one subtraction problem. So do your addition first, then subtract. I know this probably seems a little weird right now because there's no numbers. So let's take a look at some examples here. So, hey, I've got my 2x2 matrix. I'm trying to calculate the determinants. So I'm going to start top left, go down to the right. So I'm going to take 1 times 5, and I'm going to subtract bottom left to top right, 2 times 3. And I'm going to get 5 minus 6. So my determinant is going to be -1. So, like I said, most people like 2x2s. They're a little easier to work with for the simple fact that it's just those two quick products and subtract them. If we look at B, now we've got a 3x3. So we will keep working with those. When we have the 3x3, remember, we need to bring the first two columns out to the right of our matrix. So to the right of this matrix, I'm going to go 2, -2, 1, -1, 0, and 2. Now, I like to draw my lines. It helps me keep everything straight so that I can get these down in a nice ordered fashion. So if I start at the top left going down to the right, we're going to get, and I always put these in parentheses, 2 times 0 times 1, 4. Plus, going down to the right, I'm going to move to this -1. I'm going to go -1 times 1 times 1, -1 times 1 times 1, plus 3 times -2 times 2. 3 times -2 times 2. And I'm out of 3 sets of 3 diagonals to multiply, so I'm done there. I've done those 3 diagonals. So if you have a 3x3, you need 3 diagonals. If you have 2x2s, then you're going to end up with your 2 diagonals. So now we need to subtract, and I'm going to put this below this just because I'm out of room. If I could widen my screen and extend my smartboard, that would be nice, but I can't, so we're going to work this way. So the red and the blue are still the same problem here. If you guys have room on your notes, you guys can go off to the side a little easier than I can. If you can fit it, that's great. If not, you can go off to the second row like I did. So we're going to go starting at the bottom left. 1 times 0 times 3. Plus 2 times 1 times 2. Plus 4 times -2 times -1. Okay, when I simplify my blue, so I don't care if you guys take this step by step or you plug this into your calculator, but in blue, you're going to end up with when you simplify this, I just plug it in the calculator, I get -13. And I'm going to subtract whatever's in red, and I plug all of this in red into the calculator, and I'm going to get 12. So I have 13 minus 12, which will give me a determinant of -25. So that's how you're going to calculate determinants. I know right now this is a new topic that we're introducing, but we will use determinants to help us solve some problems here in the future, and then I've got an application of determinant that we're going to talk about right now. You can actually use the determinant to calculate the area of a triangle. If your triangle is on a grid, your XY plane that you guys graph on, your vertices, the corners of your triangles, are going to be at ordered pair points. So what you do is, notice, you just list your 3x values in a column, you list your 3y values in a column, and then your third column is all ones. The reason we do that is because we're keeping it all within the same plane. We're not going into a third dimension. So those are all the same, and for this to work, we're finding the determinant. And then we're going to take plus or minus half. The reason that it's plus or minus out here is our area can never be negative. But as you guys saw back here, our determinants can be negative. So really, all you're doing is making sure that that area comes out to be a positive value. So this is kind of a really cool application. That way you don't have to find all those side lengths and the base and the height and all of that. This is just a little different way to do it. So find the area of a triangle. So I've got points at 1, 2, 6, 2, 4, 0. So our area is going to be plus or minus 1/2, and I've got to set up my matrix so that I can find that determinant. So I'm just going to start on the left-hand side. It doesn't really matter what order you're going to get your ordered pairs in. The key is to keep your x's and y's together. So if I start with 1, 2, 1, 2, and that third column is all ones, then I'm going to move over to 4, 0, working to the right. So I'm going to get 4, 0, 1, and the last point is 6, 2. So 6, 2, and of course our 1 for the last column. Like I did before, I have to copy the first 2 columns down into the right of this matrix. So 1, 4, 6, 2, 0, 2. And now I'm going to start calculating my determinant. So I'm going to take, in parentheses, plus or minus 1/2. That's just going to tag along until the very end. So 1 times 0 times 1. 1 times 0 times 1. Plus 2 times 1 times 6. Plus 1 times 4 times 2. Okay, there's my positive direction. I'm going to subtract my negative direction, which will be another bracket here. Starting at the bottom left, working my way to the right. 6 times 0 times 1. 2 times 1 times 4. Nope, that should go to the 1. I'm sorry. Again, my inability to match things up makes this a little difficult. I will delete that, try again. There, that looks a little more square. So I'm going to get plus 2 times 1 times 1, and 1 times 4 times 2. Close my bracket and my parentheses. Again, you guys can plug the green and the red into your calculators. I'm fine with that. Hopefully by now you guys have enough knowledge of basic math that I trust you guys to do that. So you're going to take 1/2 times. In the green, I get 20 minus, and in red, I'm going to get 10. So my area is going to be plus or minus 1/2. 20 minus 10 is 10. And in this case, since 10 is positive, I'm going to multiply by a positive 1/2. So I'm going to get an area of 5. So that's one cool way that we can use our determinant here, find that area. One other thing we can do, just another example using that determinant, give us a 3x3 determinant again, and using that area. Talking about the Bermuda Triangle, it's a large triangular region in the Atlantic Ocean. Many ships and airplanes have been lost in this region. The triangle is formed by imaginary lines connecting Bermuda, Puerto Rico, and Miami, Florida. We want to use the determinant to estimate the area of this Bermuda Triangle. So, again, I'm just going to start left and work my way right and see what I get. So, my area is going to be plus or minus 1/2 times the determinant of 0. 0 is one of my points. Going right from my graph here. Then I'm going to go up to Bermuda, 938, 454, and our last column is always 1. And Puerto Rico is at 900, negative 518, and of course, last column of 1. As always, copy down our columns outside: 0, 938, 900, 0, 454, negative 518. And let's go to work finding this determinant. Starting in our positive direction, I know I'm going to need to take plus or minus 1/2, and this is going to get quite big and quite long, so I'm going to write relatively small, but hopefully you guys can follow me here. Down top left to bottom right, 0, 454, and 1. So I'm going to take 0, 454, and 1 to calculate those, plus 0, 1, 900, plus 1, 938, and negative 518. So 1 times 938 times negative 518. Close that bracket. And now I'm going back my other way, taking that negative side. And hopefully I can fit this all on here. 900 times 454 times 1. Plus negative 518 times 1 times 0. Plus 1 times 938 times 0. Let's see if I can scoot some of this over just a little bit. Scoot that over, scoot that over. There, that should give me just about enough room to get this in. So I'm going to take 1 times 938 times 0. Again, use your calculators. You don't need to. You can take these one step at a time if you want. With this 0 in there, that makes a lot of things go away. So what you get when you multiply this out, you get plus or minus 1/2. 0 times 454 times 1 is 0. 0 times 1 times 900 is 0. So I have 0 plus 1 times 938 times negative 518, which will give me negative 485,884 minus 900 times 454 times 1 is going to give me something, but the last two terms, again, since I'm multiplying by 0, those go away. I get 408,600. Subtract those. A plus or minus negative 894,484. And now, because I have a negative, I'm going to multiply by a negative 1/2 so that my area turns out to be positive. So I get that my area is 447,242. We'll get some more work with this in class, as always. Thanks for watching. I will see you guys in class and in the next video.